What's going on, guys? My name is Hussein, and let's discuss this awesome news. This is a fantastic article written by the Dropbox team where they migrated their NginX proxying needs from NginX to Envoy proxy. It is a well written, deeply technical details, and wherever the article shy or limits or doesn't disclose or discuss, they reference papers, they reference other articles, which I really appreciate. I don't like reading articles that they just make claims out of thin air and they don't back it up. Those guys know what they're doing. This is an interesting article. I do have my reservations. Some of the pieces felt like I am reading an ad for Envoy, to be honest, and it felt like someone really despises NginX, whoever wrote this article. At least of it, some like a few paragraphs felt like someone is really despises NginX. and by all means, guys, I don't hate NginX. You saw me when I made the NginX video. I had my reservation and I had some, I guess, opinions you can say about NginX and why I think a proxy should just be a proxy instead of being a web server and proxy. That's why I like HA proxy. HA proxy just started supporting static file, which I think it's a mistake, to be honest. I like, if you're a proxy, just be a proxy. Focus on being a proxy, because these are two different things. A lot of people disagree with me on Twitter. Oh my God, the Twitter mob, man, when I say this stuff. They say, no, it's the same thing. No, it's not. You focus on a feature and you deliver the proxying needs. And you're going to see that Dropbox exactly mentioned that. That's one of the features. If you focus on being a proxy, you can run fast and develop features way faster than maintaining a product that is a proxy and a web server at the same time. That just slows you down unless you have F5 money. NginX have F5 money and they couldn't keep up with being a proxy and a web server. The bugs, security, features, the HTTP spec keep changing, and how do you handle smuggling attacks with being a web server? It's just a mess. So let's go through this article. I'm not going to read it because you can do it yourself. I'm going to reference it below, but I'm going to go through the stuff I am personally interested in. The article is very long, and look at this beautiful thing. Do you see the progress bar, guys, there? How front-end engineers, how do you do this? My God, I'm just amazed by the front-end engineering community. Look at this beautiful thing. I would never dream to do something like that. I can barely write the CSS code. This is beautiful. All right, now let's get back to the track. All right, what I'm going to discuss in this channel and in this video, you're going to start seeing some YouTube chapter. You can jump into the interesting part that you like to watch. You don't have to watch the whole video. I'm going to discuss, I'm going to summarize the article a bit, and the performance aspect of this stuff, comparison between Nginx and Envoy. I'm going to discuss a little bit the security portion of the article. I'm going to discuss security. I'm going to discuss the missing feature that Dropbox claims that Nginx doesn't have, but Envoy have. That's a very interesting thing. And then finally, I'm going to discuss the migration concept, right? The migration between Nginx and Envoy, and there is a little bit of a discrepancy in the article that I want to call out a little bit. How about we jump into it, guys? So let's summarize this article. So what it says is, hey, Dropbox is a file sharing app, right? It says, hey, you have a file, and then you can stream the file and open the file wherever you want. That's the simple feature they serve. It's a complex system. All right, and they have this ability, and since you are serving almost like static content, files are static. Yeah, they support versioning and stuff like that, but they have a lot of proxying needs, and they use gRPC to do that. And we talked about gRPC. Check out this video right here, guys. But gRPC is it's a multi-directional protocol that uses HTTP2, and the moment you start saying that, it's like, okay, what does that mean, right? In a proxy setting, right? If you have proxies and HTTP2, well, you would think it's HTTP2 all the way, but they found a lot of problems with NginX when it comes to just supporting pure native HTTP2, right? With gRPC, and it's not straightforward. It is complex to build. And obviously they like the ability to have a schema, well-defined schema with protobuf, because gRPC, and that's their system in a nutshell. You can read more, right? There are some stuff that I didn't understand, to be honest, but it is a complexity. They have a lot of testing stuff and then deployment, but that's not what I'm really interested in. This is what I'm interested in. So they decided to move from NginX to Envoy because of certain reasons that they claim here. Let's start with the first one, performance. So I'm gonna jump to the part where they discuss the performance here. So they said that NginX performance, after they run some tests, it started to slow down. It gives you large tail latency when the request started to increase. And most of the time they said that because of blocking at the process level, right? And the way NginX works is it uses a worker process that spun off different child processes. That's the ancient design, right? After Apache, I believe, uses multi-threading, but NginX uses multi-processing for this. So everything is its own process. So guys, if you have a proxy and you have some backend, right, and you want to serve requests that comes to this server, right? Internally, if you look at it, you have many options to solve this problem, right? Because you have incoming requests, and these incoming requests are basically listening to this, or starting to wake up the TCP connections, right? And you have many ways to solve this. Node.js have the simplest design of a single-threaded event loop that has one thread and that just loops through different tasks that it needs to do, and it picks up and it just tries to execute that or delegates the task to something else, right? NginX does not use that model. It has the same event loop, but for every request that it comes, it immediately takes that request and delegates it to its own child process. And a list of these child processes are just waiting and spun up at the time of NginX running the server, right? And so what happens here, whenever a request, an HTTP request comes, or any other request comes, the NginX will shove it and deliver it. There is a main process, a master process, a main leader process that goes to a back end and delivers that request to a child worker process. This works great. However, the more request comes in, this worker process becomes the bottleneck. So NginX comes up with this SO reuse port idea, where instead of having one process, the main process, listening on the port 80 or 8080 or 443, all of these worker processes will be listening on the same port. And you might say, Hussein, that's impossible, because you cannot have two processes listening on the same port. Well, apparently there is. I never knew this. There is a way, if you dug deep into the Linux system or the operating system, you can allow the kernel to say, hey, all these processes are actually listening on the same port, and the kernel will take care of load balance, almost like load balancing the request to these child processes. So you throw the responsibility at the kernel or the operating system process. However, Dropbox team claims that even after enabling that feature, they saw some lag as a result of asynchronous I/O. So, and that's because the process is trying to read from disk, and although this operation is supposed to be asynchronous, right? Because it's 2020, who does synchronous I/O anymore, right? I just send a request, and that request will then be called back when I get the result, right? So I was surprised when I read that, oh yeah, even after enabling this feature, they got some tail latency compared to Envoy. And that's one reason that performance didn't meet their needs when it comes to these high demand tail latency in So especially in a mixed environment where they use gRPC and the backend and in the front end. All right, so that's performance. Let's discuss security. So this is a prop for NginX, surprisingly. So here the balance goes towards NginX when it comes to this article. It says, yeah, NginX actually has a smaller code surface, and that means they don't have as much dependency. So they don't reference OpenSSL or things like that. They actually build their own custom stuff and bake it into NginX itself. So now, as a result, you don't have dependency on other third party. I mean, when I say third party, another open source protocols. They write their own protocol parsers. They do all their stuff themselves too. And as a result, NginX has only 30 vulnerability and exposure in the past 11 years. Only 30, guys. NginX is one of the most used proxy and /web server in the globe. And they only reported 30 vulnerabilities. Something is off there. Even it's a great secure system, or some people are not, or just maybe we're now discovering more and getting more better as white hackers, white hat hacker or gray hat hackers becoming more prevalent. Now we're gonna discover more and more vulnerabilities. Who knows? It will be interesting to know these 30 vulnerabilities when they were discovered. Is it in the past 11 years, right? Or recently in the past 2 years, right? Because just looking at Envoy, in the past 2 years, Envoy, they discovered 22 security advisories. And that's because Envoy is just references libraries, right? From different libraries existing. So it reuses these libraries. And they explained that they were able, Dropbox team, they were happy with this. And it says, yeah, we know about this. This was not good enough reason for us to stick with NginX because of other reasons we're gonna come in the later in the article. But it's so interesting, guys. Look at this. They started using these tools in order to basically continuously monitoring these security practices. And we don't know what technically Envoy is a very, very new software. Envoy, by the way, is written by Matt Klein, and I follow him on Twitter. He's pretty smart guy, so smart. And then it's just fascinating how much you learn by following so smart people on Twitter, and just that's this article. It's just lists so much cool stuff. So yeah, there are some some vulnerabilities in Envoy, but they're keeping an eye on this. But that's security in a nutshell. The features, this one is interesting. This is one of my favorite part. The features of NginX, and if you zoom in, I zoom in here, look at this, guys. And that's exactly what I said 2 years ago when I made the NginX video. I felt same thing. So I was okay. there is a proxy that does only one job, and that's a proxy, HA proxy. When I start comparing HA proxy and NginX, I didn't know about Envoy back then. So, okay, this thing is a web server, and we know how much work required to build a web server versus a proxy. Yeah, there are similarities, but it's content and static content. Slowly you're gonna start sliding into CGI and stuff like that and start supporting a lot of web servery stuff. Versus proxy, you need to just be good at building rules and do proxying at layer 4 and layer 7 and TLS terminating and do these things very well. These are, to me, there are two different distinct niches that developers need to just pick one and focus on. And that's what NginX did. They started as a web server and then they evolved into a proxy. So now Envoy started as just a pure proxy, and that's clearly is going to be a winner because they're focusing on having a clean, transparent gRPC proxying, right? Now, gRPC, guys, uses HTTP too, and that's one problem that NginX has. To do a gRPC, NginX started implementing gRPC as almost like an afterthought, right? Not as a ground up thing, right? So when you do that, what is gRPC? You can do gRPC today by doing a layer 4 blind TCP stream proxy. That's easy, right? Because now that you just do a TCP all the way until the server, but that's extremely expensive because you're gonna end up creating a new TCP connection for each request, and that's extremely expensive. Hey guys, this is Hussein from editing. What I meant to say here is it is extremely expensive. That's true. However, each TCP connection will get a backend connection, a dedicated one, right? So that means you cannot multiplex and you cannot pool backend connection in the TCP mode, right? Because every request, every connection will end up having a dedicated connection as long as the source IP and the port are the same, and that will basically expand the number of TCP connection at the backend, and that's kind of limits memory and then obviously more work on the proxy level, and that's it. Compared to multiplexing pooled backend connection into one TCP connection in the back, or many TCP connections, right? So that's what I meant to do. It's like request was the wrong word to use, right? Because we know that we're gonna end up we want to pool the backend TCP connection as much as possible, and NginX didn't do that. It just starts spinning up TCPs on the back end without multiplexing, and that was a deal breaker for Dropbox. And I don't disagree with that at all, because yeah, that's a problem if you don't do that. And look at this, HTTP to backend. This feature allows us to greatly reduce the number of TCP connections. That's true, right? I don't believe HTTP 2, it did not have HTTP 2 backend at that time. Again, they were using the NginX free version on this, and nothing wrong with that, but as a Dropbox, I would imagine they would pay a little bit more money to get the enterprise version of NginX. Now, I don't know if in the enterprise version of NginX had these capabilities or not, God knows. But look at this, HTTP 2 on the backend. This feature allows to greatly reduce the number of TCP connections between our traffic tiers. Why? We talked about that, guys, many times on the channel. Check out the HTTP on the backend thing. Because if you have HTTP on the front end, which is gRPC, now if you create an HTTP 2 TCP connection, now you can use streams in that backend TCP connection to represent requests from multiple clients. So technically, you can reuse the TCP connection instead of wasting it. And instead of wasting it, just spinning up a new TCP connection. That's extremely powerful. Apparently, Envoy supports that. NginX, as they claim, I'm not sure about that, does not support that. Okay, gRPC web, obviously guys, gRPC is not supported on natively on the browsers, and the reason because the vendors who want to write gRPC clients, mainly Google, do not have low-level access to HTTP2 libraries in order to play and fingle with the, what the hell does fingle mean? Fingle with the stream level HTTP2 socket. They only have they can do as much as we can do, which is fetch. That's pretty much it. So because of that, we can't really do gRPC on the web, right? Unless someone comes down and build a nice API in the browser, and the browser community have to agree on it. Jeez. So that's another 7 years. Good luck doing that, right? And just people agreeing on stuff. No, that was not gonna happen. So either Chrome, which is the one who built gRPC, they can just submit an API, to be honest, in Chrome, and stuff with the Chrome, then take the advantage. But until then, we have a native gRPC. We have to do this hack, which I don't like, to be honest. It's gRPC web is a proxy that you spin up locally and on your browser. I don't know if it's an extension or a service proxy, or what is it called? Service, I forgot its name. Service worker, right? It will just basically listen, and you send normal REST calls or GET POST calls, and that will be transmitted as a gRPC to the backend, right? So technically, you are locally communicating in pure HTTP localhost loopback between yourself as a browser and the gRPC web proxy, and the gRPC web proxy is communicating as basically another gRPC layer at the backend, right? So now that's what they mean by gRPC end to end here, right? So yeah, they do say that's end to end, but I believe they do have layer 7 TLS terminating proxies in the middle to look at the traffic to make decisions based on that. Otherwise, it's useless. So, right, they have to look, they terminate, they look at that, they try to understand stream level gRPC and then make another stream request on the backend. So it's like stream, almost like stream proxying. That's a very interesting word because it's very confusing. Stream proxying in NginX means TCP streaming versus stream proxying. What I meant is stream HTTP2 stream. That's why I hate the word stream, guys. Why did we pick this stream? Should be channel, right? RabbitMQ did that. And SSH way back used channel. Why Google? Why did you pick stream? It's just so confusing. It should have been named channel. All right. So that's pretty neat. I love it. I absolutely love it. All right, migration, guys. Migration. Look at this, guys. So here, we'll come to this. Issues we encounter, right? Let's go back. So with migration, they say we had seamlessly migrate a system that already handles 10 millions of open testing. So that's what the first time I read it, I was like, oh, they managed to seamlessly migrate the system from NginX to Envoy, right? Seamlessly. Then at the end of the article, they say, well, not really. Not really, because then they say, well, migration was not really flawless, to be honest, right? So it took them almost more than 6 months, 7 months to do the migration, and it took them over the half a year to do the migration. So it wasn't that simple. So they ran NginX and Envoy proxy in parallel, and they used DNS to start just flipping the IP addresses at the DNS level to point slowly from NginX to Envoy and start managing the traffic slowly until they removed all NginX traffic at all. All of it just gone. However, it wasn't flawless, and this is so awesome. Let's go through it. NginX, it was built long time ago, guys. So they run into a lot of stuff, and they did some stuff, some features they implemented, let's say to mask bugs. They were supposed to be bugs in the backend servers, but they masked it, and they took care of taking the blame and fixing it. An example of this is the transfer chunk encoding. So we talked about HTTP smuggling in this channel a little bit, guys, right? So NginX wrote a lot of code to smartly take care of transfer encoding and content length duplicates, right? Which attackers use to smuggle bad content into their request, right? Envoy just says nope, nope, don't accept things that takes both of this, right? NginX used to say, okay, I'm gonna accept it, but I'm gonna deal with it later, right? But Envoy says nope, just block it, all of it, which to me, I think that's the best approach. Just block it, because that's a bad request if you're sending me a content length and HTTP chunked encoding. That means you're either an attacker or could be just a naive client, a simple client, which is the case. They had a lot of HTTP 1.0, by the way, clients, which I was surprised. It's like apparently Dropbox being used for a lot of stuff, right? So yeah, so you'd see these features, right? They're like, for example, ports in virtual hostname. NginX allows receiving host headers in both forms, either example or example pool. We had a couple of APIs that used to rely on this behavior. First, we worked around this by duplicating our vhost in our configuration. Okay, that makes sense. But later added an option to ignore the matching port in Envoy side. So that's NginX. This is just features in NginX that technically didn't exist in Envoy. And what they are doing, some of them are, to be honest, these features shouldn't be features. Should be, you can consider it a bug that it shouldn't have been fixed, right? It should just fail, right? But it's just all of these things. Like take a look at this buffering. NginX allow request buffering on disk. This is especially useful in environments where you have legacy HTTP1 backend that don't understand transfer encoding. NginX could convert these requests with content length. So NginX was smart enough to look at the backend and say, do you support HTTPS content chunked, right? And if the backend doesn't support it, it doesn't say fail. No, NginX actually says, wait, the backend doesn't support it content chunking, because these the server side events, guys, the server sent events that we talked about, right? The backend doesn't support it, but doesn't mean I can fail. So NginX started basically buffering all the content until it reached the end, and then sending it as just one request to the backend. Obviously, Envoy did not support that feature, so they I don't know what they did. What did Envoy has a buffer filter, but without the ability to store data, right? So they basically started. Dropbox contributed, by the way, to the Envoy project by implementing this feature as they find, oh, NginX apparently is a big thing, right? so they started implementing this feature in Envoy and then pushing it to implementing this feature locally in Envoy and then pushing it upstream to the open source Envoy project. And I need to make an Envoy proxy. Type below comment section, make Envoy, so we can make this fair. Or just type Envoy, so we can write, so we can do this thing. Guys, this is, man, what do you guys think about this stuff? This is a very interesting article. What's next? HTTP 3. Everybody's talking about HTTP 3. I'm not sure we need it. I mean, Dropbox will need it because they use gRPC all the way, right? Even in the web, because they are using gRPC web. So they are suffering now with one limitation in HTTP 2, guys. The TCP retransmission problem, right? And here's the problem in a nutshell. TCP, when you send a packet in TCP, you get an acknowledgement from the server. And this is just a packet level, right? That's how TCP works. And HTTP2 uses TCP. So if you send a packet, and if you don't receive that packet, right, each packet has a serial number, which is the SYN. They agree on the SYN-ACK, right? Each packet is serialized. Now, if you send packets and you receive like packet 1, packet 2, packet 3, and you receive an acknowledgement of packet 3, guess what? The client will wait and until, or even the server and client will wait until the server acknowledges 2 and 1, despite 3 has been received, right? That's because they want to order stuff, right? That's a problem. And here's why. HTTP2 uses multiplexing, and it sends every request as its own stream. So a stream will be translated into packets, right? So to the TCP stack, there is no information that says this packet belongs to this stream because it's a higher level. To it, it's just data, right? So now, if you successfully received all the content for stream 1, which is request number 1, for example, let's say, but stream 2 were sent, well, those packets were sent, but let's say it's not acknowledged yet. Guess what? Right? Guess what? Stream 2 is now, stream 1 is now blocked because stream 2, there's a stinking packet that hasn't been received. Who cares? Stream 1 is its own request. You're blocking me because stream 8 or stream 9 has one packet that has not been acknowledged. That's what's happening on the backend, right? That's why HTTP uses a lot of CPU power to just do this thing and assemble the streams from packets. So it's just so interesting to me, all this stuff. And Envoy Mobile is another thing that I don't know really much about, but apparently they don't use proxying here. They just use a library into mobile to just, from day one, you can communicate with gRPC, with HTTP2 and HTTP3 in the future, right? So now, this is the problem with HTTP2, guys, right? So now, they want to move next to HTTP3, which uses Quick, which uses UDP, which implements this streaming thing on the application layer, right? And that's really powerful. Now you don't have this, what is it called? I forgot what it's called. Is it pipelining? Head of line blocking. Thank you. I don't know how much I'm thanking. But yeah, head of line blocking. That's what we're blocking because there is a stinking packet that has not been acknowledged in stream 8. And you're blocking all the other streams just because there is a packet that is received in stream 8. So in Quick, only that packet will not be acknowledged, and as a result, only stream 8 or stream 9 will block the communication. However, streams, any streams that receive the packets will be just gone and everything's good. But yeah, guys, so they claim that everything was dandy and seamless, but not really. So there was a little bit of a contradiction here. So I didn't really understand that. I don't know, man. Maybe it's just my English. It's just me, right? They just say seamlessly migrate, and then they say, "Whoa, it wasn't really flawless." So I don't know about that. But nevertheless, an excellent article, well written. Good job, Alexei and Oleg. Great content. Please give us more beautiful stuff like that. I learned so much, and from this article, I have now 7 papers that I need to read as a result because I want to understand more about this stuff, to be honest, especially when it comes to multiprocessing versus multi-threading and which one is better. Because I didn't quite buy that, to be honest. They moved from NginX because it's a multiprocessing to multi-threaded Envoy because it's better because there's one problem they reference. Envoy, if it uses multi-threading, if the main process died, all the threads is dead. That's even worse to me than multiprocessing. Yeah, you can argue that multiprocessing has has or more overhead because every process have its own process overhead that the operating system do. But I don't know if it's that bad. But again, we're all learning. We're all gonna learn. We're gonna communicate. Guys, what do you think about this whole thing? Let me know in the comment section below. I'm gonna see you in the next one. And we're gonna keep learning. I want more of these beautiful articles from the software engineering community. This is excellent. We want this transparency. Dropbox, great job. Thank you so much. Yeah, you a little bit threw a lot of shade on NginX, to be honest. I wouldn't do that. But you did give it some praise, and I like that. So thank you so much. I'm going to see you in the next one. You guys stay awesome. Goodbye.